Welcome to the lesson on angle comparisons. In this lesson, we will make note of a special relationship between the sides of angles and what relationships it can make. Now, the way in which angles are oriented can determine a particular relationship between two angles. To look at it more specifically, we'll take a look at two angles and how we can solve a proof between them. Now, if two angles have their sides respectively perpendicular, they are equal or supplementary, so one or the other. So now I'm taking a look at two angles here, ADC and ABC, and I want to see if angle ABC and ADC will end up being either equal or supplementary. So they're the same or they equal up to 180. Now, will D be equal to B? Now, I do know that these angles have made, or the angles have crossed so that angle C is 90, angle A is 90, and because 1 and 2 are vertical, they must also be congruent, which means angle B and angle D must be congruent. There's only one measurement left for those third sides. So those angles do end up being congruent. But how can we draw this? How can we look at a variety of examples? And we'll do so on a dot plot to just make things a little bit easier. With this first one, I'm trying to construct an angle that's equal to ABC with the vertex P. So I see that the ray PD is already going to be perpendicular to BC. So that means from vertex P, I can go ahead and draw another ray that will ultimately, even though they don't connect, be perpendicular to AB, the other side. That's going to show me that angle P will be congruent to angle B. Now in example B, I got to construct an angle that's supplementary to ABC with vertex P and ray PD. Now since ray PD and BC are perpendicular, I must make my additional ray also perpendicular to the other side, AB. In that sense, I know that this big obtuse angle P is going to be equal to 180 with the smaller angle B. Lastly, I want to construct an angle that's equal to ABC with vertex P and ray PD. Now, because BC is parallel to DP, I must make an additional parallel side, and those two angles will be congruent. Even though I made that angle from the wrong vertex, you can still see the same idea being illustrated. Now, how does this scenario apply? Now, these principles are very important because it relates to the law of optics, which is a branch of physics that says that if a ray of light hits a plane mirror, the angle that the light is reflected is equal to the angle that the light hits the mirror, which means that if a light source makes a 28-degree angle with a mirror, it's going to be 28 on the other side, which allows us to find the big middle angle in this case, which would be 124. Now, to take a look at a lighter example, we can apply these same principles to a simple game of miniature golf. Now, imagine that in order to get around a large barrier on our golf hole, you're going to bank your ball as shown. You're going to make it hit 3 walls and then hopefully go in the hole. Now, if this first angle down here at the bottom is 35 degrees, can we connect enough of these principles to find the angle 2? Well, I know that if angle 1 is going to be 35, the angle on the other side of this ricochet must also be 35. And of course, the golf hole is rectangular, so this is going to be 90, which means my third angle in this right angle triangle must be 55. The angle on the opposite side of that ricochet will be 55. Because that's 90, this angle just next to angle 2 is going to be 35. And because the other angle on that ricochet is 35, I can go ahead and subtract both of those from 180 and get my angle 2 as 110. Now, as great as this seems, just like me, it may not help you improve your golf game, although the math behind it is indeed very interesting. Now let's take a look at a practice problem to determine how I can use these principles to solve an applied problem where I'm looking for either angles or I'm trying to solve for x. Now in this particular problem, I'm looking for 3 angles, DEG. I'm looking for the angle EGC down here at the bottom, which is represented by a regular x. And lastly, I'm looking for the angle DCG, represented by 3x minus 2. Now, I will notice here that because this is a right angle triangle, it must be a right angle on the other side. Subtracting both of those from 180 would lead me to believe that this angle is 54. Its vertical pair must also be 54. And continuing along with this pattern, I can find that angle DEH is going to be 36. Now, DEH makes a linear pair with DEG, so DEG must be a 144. Of course, I subtract from 180. So now, even though I've been dealing with triangles, I know that I have a quadrilateral here with an angle that's already 90, an angle I know as 144, x, and 3x minus 2. So I can combine all those to equal 360. Now I can apply my principles of algebra, subtract 90 and 144, or rather, first I can combine like terms. So 232 plus 4x will equal 360. I will subtract 232 from both sides, so 4x will be equal to 128, and then x will be equal to 32. Now that I know x is 32, it gives me this angle down here at the bottom, EGC, so that angle will be 32. I can plug 32 in for one of the other angles, plug it in where I see x, so 3 times 32 is 96 minus 2 will give me 94, so DCG is 94. And to recap, the first angle we found, DEG, was 144.